All right, what's up, everybody? So, here, let me turn this up a bit so I can. Okay. So, what I decided to do today was, this is just spontaneous, I didn't tell anybody. I decided that I was going to go ahead and do the question of the day, just do a live, and this way I could post it. I'll also post a hard copy of it, but I thought I'd go ahead and just post a video here. So, I haven't really looked at this question. A lot of times, hold on, guys. I almost lost my camera there. All right, now I got to reset this here. All right, give me a sec. I've had this thing set up here for a while. All right. All right, sorry about that little mishap. All right, so, gee, I lost my train of thought here. All right, so yeah, a lot of times when I post a question, I just find something that's really interesting. I post it and I don't look at it ahead of time. So I'm going to be working through this, probably the same as you guys if you haven't looked at it. So let's see what we can do here. Now, and hopefully my camera won't fall again, so I'll kind of have to watch that. But if we look at this, okay, so this was the molecule that we would start with, and then this is what we've got. So I can't really fit it all on here. I kind of didn't set this up properly. But what I always do when I do a question like this is I look at all my reagents in my starting material, and I see what is, probably the best way to put it is what's the most reactive, okay? So if I look at this starting molecule right here, there's nothing really here that stands out to me that I would be concerned about. This is probably going to be very stable, not really going to have to worry about it. We have a cyanide group, we have these methyls, don't have to worry about that. We've got an alkene, and then we have an alcohol. This overall is not concerning in terms of figuring out how to start this. So then what I'm going to do is I'm going to look at my reagents. And we'll notice here that we've got a transition metal. So typically when you have a transition metal, you want to think about that as an electrophile, because that's going to be partially positive or positive. And so that's, again, we're going to be thinking about that doing something. But really we want to look at this. We've got an alkene. It's all by itself. It's not really interacting with anything. So I wouldn't worry about that. We've got an alkene here, but this is a little different because we've got this double bond. And if I were to draw them in here, I'll put two sets of electrons. We have this system now where these electrons can talk to that alkene. If you remember, I'm just going to draw this, but if you remember in the last post I had that I talked about when you have a pi system and you have lone pairs, all these things can interact, whether that's a charge. I think I talked about a charge actually. Well, that can interact right there, okay? And if I just draw this right here, if we think about this, we can have our double bond and an oxygen. And if we have these lone pairs, just to show you, through resonance, we can push these through. We can dump those electrons out to the side. And what that would give us here is we would have O. This would be a minus. This would be a plus. That would be a double. And we would have that, okay? So you can see that from this system right here, just on its own, to maybe a small degree, we would wind up getting this electrons interacting with this double bond and giving us this charge separation. Now, what's really going to push that in one direction would really be this. So now if we think about this question, now that we see that the most reactive part is going to be this right here because we have this vinyl ether. Now what's going to happen between these two? Now we can think about this, that this mercury, this is almost like we could think about in terms of an oxymercuration, right? If we have a double bond and we treat it with mercury, we can get this mercurinium ion. Well, more than likely that's probably, just from looking at it right now, that's more than likely probably what's going to be happening. So if we think about this, we could draw just an intermediate, just to show you this. Let's say we had this. And we could think about, for example, the mercury interacting with that system there. And we still have these lone pairs. And this will be kind of like the driving force to kind of start this whole process. So when we have this, we could imagine intermediately, whether this sticks together or this falls apart, we could imagine it could either be in this form or we could push these electrons up. We could push those electrons over there. Sorry, my markers are sticking. And I see hello, Muhammad. And what this would give us would be a double bond. We could get, sorry, I don't have a lot of space. I just decided to do this at the last minute and didn't leave myself much space here. Okay, we could imagine something like this. Just generally, we're just trying to get a general idea here. So we could imagine that the two things that we might possibly want to think about is that we could get a mercurinium ion, and there could be some sort of, not a completely bond breaking, but an interaction this way. Or we can think of maybe there's an intermediate where we actually form what's known as the oxonium ion, and then we've got our mercury out here, and then we could do something with that, okay? So either one of these really, you could kind of think of maybe somewhere in between one or the other. At this point, we'll just pick your favorite. I'm going to go with possibly somewhere in between where this is going to be facilitating. Maybe it's not all the way here, but what we're going to be thinking about here is this oxygen is going to be participating like a neighboring group participation where it's going to start to break that bond. Now, if we go back to our molecule, I'll slide over here. We can see that overall, if we know that this is our electrophile now, this system right here, then that means we're looking for our most nucleophilic part right here. Because as I talk about in organic chemistry, the heart of every reaction is a nucleophile and an electrophile, and that's what you're looking for. So we've identified this whole mess over here is our electrophile, so that means this is going to be our nucleophile. What you're typically looking for is either a fully negative charge or lone pairs that are going to be very accessible. We've got lone pairs on the nitrogen, but by far this oxygen right here is going to win out, these electrons right here. So we can see from this top structure then that what we're going to wind up doing is we can take these and imagine, I'm not going to draw it all out because we've got it down here, but imagine that this electrons right here could come in, or I guess I could draw them here, these could come in and attack that position right there. So if I just drew that in, I know it's getting messy, but just show that. We can imagine we could do that and then pop those open, okay? So let's see if we can kind of do this now. All right, so let me see if I can take all of this and we'll just use what we have already here. And hopefully I can remember all the structures, okay? So just generally, we won't worry about all the minute details of here and there and this and that, but essentially, if we attack that, then that would give us, let's see if I can draw this, remember this was here, here, this would have been oxygen, let's see here, I'm trying to keep it the same way. I should have kept it on there. Let's do it this way. So we had our oxygen here, this would have been there, and then we would have had our Hg out there, some sort of form. This was a positive charge, and we had that. Okay? Hopefully I drew that correct. And then let's imagine, so like I said, I'm not doing all the steps in this mechanism. I just want to give you guys a general idea of what's happening here. So we can imagine that then we've got that hydrogen. So we get this intermediate right here. Okay? Whoops, hold on, I did this. See, trying to do things too fast. Okay. So we can say after the Lewis acid interacts with our vinyl ether, we can get this intermediate right here, which we can see is an acetal, okay? Now, we can imagine still that Lewis acid could help facilitate in here. We can imagine that at this point, maybe we could get coordination, for example, on this one. Maybe we use it, maybe we don't. There's a lot of things that we could think about, but whether we use it or not, the main reaction that's going to be happening now that we can think about would be that these electrons could go down. And this is literally just breaking an acetal. I'm pretty sure everybody on here is familiar, whether you're an undergraduate or particularly if you're a graduate student, just acetal formation. So we can see if we follow those electrons around, we're going to kick out all of this system out here. Okay. And if anybody has any thoughts as we're going along, please feel free to make a comment. Like I said, to those of you that just jumped on, whoops, that's not there. I post the questions during the day and then I don't really think about them and I kind of try to work them out on the go as I go, and that's what I'm doing right here. So we get this intermediate here, all right? So we've got, let me just redraw this because this looks really strange. So let's try to redraw this in a different form. So ultimately we should wind up getting, whoops, wrong color. We would wind up getting, so it'd be here, let's see if I got this right, this, and then we had our mercury species out there, okay? And if I remember correctly, I think this was mercury O2 CF3 2. I don't have it written down, but I'm hoping that's what it is. But we can just say essentially that this is going to be some sort of anion. And we can imagine here that we've got this intermediate now, okay? And now we've still got this mercury on here. So we've got this positive charge, and now we just need to get rid of this. So probably the anion of this, we could just really put some sort of X minus, could then come back in, I think, if I'm not mistaken, that it was this, trifluoroacetic acid. You can imagine that then that could come back in. We could push these down, and we could dump those electrons on there. We won't worry about the whole structure there, but what that will wind up giving us is this. Actually, I'm going to need part of it, I just realized. So let's do this. Let's draw that. Actually, I have a better idea. I always sometimes try to make things much more complicated. Let's do this. We're going to swing this over here. And I'm going to redraw this. So we can see that we're going to push all those electrons down. And if we redraw that, what that should give us is that structure right there. Now, obviously, in this point, I've drawn it in this particular form, and now it's going to be probably much easier to see. But the whole point of doing the mercury, I think that would be mercury trifluoroacetic acid with that diene, we'll call it, with this, was to give us this vinyl ether right here. And as we already said, vinyl ethers are pretty reactive. Or not pretty, I shouldn't say pretty reactive, they're reactive. But what's nice about this, that we've got this set up, is if we look at this, we have 1, 2, 3, 4, 5, 6. It's perfectly set up to do a sigmatropic rearrangement. So we'll get rid of all of those. And then we just track along the electrons. So we can go here. We can move these up there. And then those can go down there. And if we follow those along correctly, or I guess I should say if I'm following those along correctly, you can see that all this stuff out here was really just to try to confuse you, see if I could throw you off. But if we track that along, we're going to get, let's see, where are we here? Now I got to make sure I keep track of this. So this is going to give us a double bond here. So let's start here. We're going to take this bond and we're going to flip it up. We've already got that carbon, which is right there. So we're going to flip that. That's going to give us a double bond. Then what we're going to do is we're actually going to break this carbon-oxygen bond there, so that line is not going to be there anymore. But what we've got here is we're going to take this bond that was there, and now we're going to rotate it down here. So if we track that, we're going to now have a double bond there. That one is gone. And then the last one that we have to do is rearrange that. This one is obviously still here. We don't want to lose that one. But then we can move that bond up there. And then I guess we'll just put everything in there. So that'll be here, 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 and C. CH3, and then I think this one was back, CH3. And I know you can't see that, I just realized that, so let's go back here, sorry. So let me go back through this. This is why I'm doing this. So what I was saying here is that if we go through this and we track this through, let's start with this bond here, okay? We're going to take this bond and we're going to rotate it up. We've already got this carbon here, so that means we're going to make a double bond. If we go here, we see that we're going to break this carbon-oxygen bond, but we're going to leave this one alone. So if we go down here, that's going to form a carbon-oxygen double bond. And then we're going to move this pi bond, but this carbon-carbon bond is still going to be there, and we're going to form a new one there. So we can see that we're forming a new one here, and we're breaking one there. So we wind up getting this structure right here. So this is going to be our structure B, and this one right here was structure A. All right, guys, so for those of you that just jumped on, I just decided I didn't let anybody know, decided to go ahead and do this live. Excuse me, and post the answer to the question of the day. I'm going to put it up for 24 hours, as you know. And then I'm also going to do a hard copy post of just the intermediate structures, but I at least wanted to do this to show you. One last point is I had talked about, well, here, let's do this. Let's flip this around here. Grabbed it. All right, what's up, guys? So I had talked about at my last class that I was going to do NMR, that you guys like unanimously decided that you wanted to do an NMR class. I see somebody wrote a comment. I will direct message you. Okay. I talked about NMR, but what I'm going to do, I decided is I get so many questions about who am I? You know, it's like the question of somebody's life, right? Who am I? What am I? But anyway, I get so many questions about what am I, what do I do, who am I, you know, what's the best book? So I decided instead of doing a class on something from the book, I'm going to go ahead and do like a Q&A. So if you have questions, send them. If not, I'll just use all the questions that I've gotten over the past couple months. And I'm going to try to set that up on Wednesday. I'll post something about that to let you guys know. But I'm definitely going to do that to try to answer some of your questions that you guys have been asking. So with that, all right, guys. I always say that. All right, everybody, because it's not just guys. Hope you guys have a good one, and look forward to seeing you soon.